Hey everybody, today we're going to take a look at radical operations. So we're going to be adding, subtracting, multiplying, dividing radical expressions. So you're going to need your flip chart organizer. Your perfect roots chart is also very handy. That's that pale yellow cardstock that you filled out. A calculator and something to write with, of course. Make sure you take good notes. So remember that this is your little foldable that we're writing your notes in, and you can see we're on the third tab down here, Radical Operations. So everything we write today, we'll be lifting up those first flaps there and writing on that last page. Let's see what we already know. You do not need to write this part down, but let's remember where we've been. When you simplify square roots, like the square root of 50, remember that you're working to break it apart into something times something, and you need to have one of those be a perfect square. So square root of 50, I'd probably use 25 times 2 to break them apart, because the square root of 25 is 5, and the square root of 2 then just stays the square root of 2. So simplifying radicals involves looking for a perfect square in this case, sometimes a perfect cube if it's a cube root, and so on. Let's look at the second example. We've also taken a look at different types of roots and what we do when we have variables on the inside. So let's look at just the cube root of 54 here first. The cube root of 54, I would probably split apart into 27 times 2. So I'd have the cube root of 27 times the cube root of 2. The reason I'm choosing 27 times 2 is because 27 is a perfect cube. He's found in that cube column in your perfect roots table there. So the cube root of 27 is 3, and the cube root of 2 is something I don't know, so I'm just going to leave that part alone. This is what the number part looks like. Now let's talk about those letters again. Let's review those variables. This is a cube root. It will not cancel with an x to the fourth, but we ask ourselves, how many groups of 3 can I get out of an x to the fourth? And the answer is 1. So 1x will come out because there's one group of 3 that I can take out. And when I take that group of 3 out, I'll have some leftover x's. How many x's will be left over on the inside? Just 1, since I've taken that group of 3 x's out. So this is what I got for the numerical value. This is what I got for the variables. Now it's time to put it together. Who's on the outside then? There'd be a 3 and an x. And who's left over inside the cube root sign? There's a 2 and an x as well. So this would be my final simplified version of that problem. So using all of this simplifying skills that we've been working on here, all of our simplification, we now need to do radical operations. And they're going to involve remembering how to simplify things. So this is what your little flip chart looks like when you open it up. Down on the bottom, make 4 little regions here. Okay, 1, 2, 3, 4, 4 little regions. We're going to do 4 examples and that's it. And up here, we're going to be writing some things up here on what to do when I have certain operations. So let's take a look at this first example. This one gets written inside that first box that we made down there on the bottom half of your foldable. So I have the cube root of 4 times the cube root of 16. Neither of those are really nice values. There is no cube root of 4 and there is no cube root of 16. They are being multiplied. And radical operations and radical rules, remember, remind us that you can multiply the 4 times the 16 and write them underneath one cube root symbol and take another look at what this value is. So 4 times 16 is in fact 64. And now when I look, I say, well, hey, I got the cube root of 64. And if I look at my perfect roots table, you guys, there is a cube root of 64. It just happens to be the number 4. So because I multiplied the 4 times the 16, 4 times 16, and turned them into a 64, that was actually good because then I knew that it simplified further. Let's take a look at our second example. What if there was division? What if I had the 4th root of 80 over the 4th root of 5? Neither of those are perfect roots there either. So could I do the similar thing that I did to multiply and just divide the 80 by the 5 and write it underneath one radical symbol? Sure. 80 divided by 5 happens to be 16. So if you take the 80 and divide it by 5, it works out to be 16. And 16 does have a perfect fourth root. It is 2. So my final two answers worked out to be nice values there, and I wouldn't have seen that if I did not understand radical operations. So in your flip chart, or not quite yet, let's think first, what about if those problems had been cube root of 4 times fourth root of 16? Could we have combined those into one radical sign? No. This is a cube root. This is a fourth root. That means I cannot combine them underneath one radical sign. And the same thing would be true if that had been a square root of 80 over a fourth root of 5. The index values, okay? The index here has to match the index here in order for me to go ahead and simplify that underneath one radical symbol. So now to your foldable. On the top there it says multiply or divide. Make sure you write that in there. If I'm going to multiply or divide, or if the problem asks me to multiply or divide, I need to look if the index is the same. You can use one radical sign then and actually do the multiplication or do the division. So we're looking to make sure that index is the same, and then I can go ahead and just multiply or divide like it asked me to do. So we've talked about multiplication, we've talked about division. What about adding and subtracting? So here's our third example. What if we have a cube root of 5 plus a cube root of 40? A lot of people would think, hey, make it a cube root of 45. But you can't do that. With addition and subtraction in algebra, you guys, we got to make sure we have like terms. Okay, things have to be alike before you can add them together. A cube root of 5 is very different from a cube root of 40. It's like adding x's plus 3y's. I can't do that because they're not alike. I can't make them 3xy's. So I need to think about this cube root of 40 in a different way. So if there's a large radicand number like 40 here, we would go ahead and simplify this first and then take a look at this problem maybe in a new light here. So the cube root of 40, if I look down my perfect cubes column in your chart, one of those we need to use to break apart our 40. Let's use 8. The cube root of 8 times the cube root of 5. 8 times 5 makes 40, so I'm just splitting them apart. The cube root of 8 is 2. The cube root of 5 is something I don't know, so I'm going to leave that alone. And now I'm going to drop down the rest of this problem here. And now if I read what I have 1 cube root of 5. That's right, there's like a 1 up in front of here. I have 1 cube root of 5 plus 2 cube roots of 5 makes, that's right, 3 cube roots of 5. One of them plus 2 of them makes 3 of them. And the of them happens to be 3 cube roots of 5, okay, or the cube root of 5 in this case. So this is my final answer. I needed to make sure that I have like terms before I can go ahead and add those values together. So I have to simplify first before I can add. Let's look at a subtraction example with the same lens here, or the same idea. I have a cube root of 54 minus a cube root of 2. So we'll go ahead and split apart that 54 into cube root of 27 times 2. And now, can I do the cube root of 27? Yes, that's 3. So this is 3 cube roots of 2. And I'm going to drop down the rest of the problem minus a cube root of 2, which is the same thing as 1, okay, a single cube root of 2. So 3 cube roots of 2 minus 1 cube root of 2 makes 2 cube roots of 2. So this is my final simplified answer. With addition and subtraction, it's hard to like remember, but you got to find a way to remember that you have to have like terms before you add or subtract. We don't just add and subtract the numbers we see inside those radical signs, okay? It's all about like terms with addition and subtraction of anything in algebra. Fractions, x's and y's, anything. You have to have like terms. So let's add that to the top of our foldable here, and then we are done. We need to add or subtract, question mark. We must have like radicals. So we must make them have like radicals, and then we can combine like terms. So we must be talking about the same thing. Square roots of 3, cube roots of 3, cube roots of 5, fourth roots of 5, whatever it is, we have to have like radicals first, and then we can combine like terms. So if you've taken all those notes in your foldable, you're ready to roll for what's coming next. Thank you very much for taking good notes today.